introduce herself to you. All over to you, ma'am.
Thank you, ma'am. Good evening, everyone. How's everyone doing? All right. Okay. So my name is Aishwarya, and I'm from Delhi. I have an MPhil in botany, and I have been teaching for competitive exams for almost 4 years now. And my expertise obviously lie in science. And one thing you have to know about me is that I am very curious, and that's what I want from you also. That you ask as many questions as you can. Only then there can be only two things: either you understand everything or you've understood nothing if you're not asking questions. So our sessions have to be very, very interactive. We have to discuss a lot, and we learn together, find tips and tricks so that we can crack our exams. That's all from my side.
Thank you so much, ma'am. So children, allow me to share my screen so that I can give you a short PPT. In case you want to note anything down, you're most welcome. So is my screen visible?
Yes, ma'am.
Okay. So children, a very warm welcome to this demo and interaction program for class 7 science batch 1. As you already know, Olympiad Success is India's largest online preparation platform for Olympiad exams. And Olympiad Success Live is India's first exclusive live classes for Olympiad's preparation. School Plus is one of its own kind of yearly program that includes 8 courses that really matter at this point of time in your life. These 8 courses include mathematics, English, science, logical reasoning, communication, both spoken and written, Vedic maths, and coding. So here you can get one-on-one online CBSE, ICSE, IGCSE, and IB classes for grades 2 to 12. Also, you can get one-on-one preparation classes for international mathematics Olympiads like SASMO, CSMO, CMO, HKIMO, TIMO, Math Counts, US Common Core Math Competition, Math Kangaroo, PRMO. So meet our international rank holders for the year 2021 and 22. These are all star performers. Quite a few. Now, you can get group sessions. So this is all about group sessions with around batch size of 20 students. These classes will be delivered through Zoom by seasoned tutors who have significant teaching experience. So you get 3 sessions per week, Monday, Wednesday, Friday. Timings will be 6:30 p.m. to 7:45 p.m. with 5 minutes break in between. So the flow of the session would be 35 minutes of class followed by 5 minutes of break followed by 35 minutes of class. So the sessions would include a mix of theory, practice questions, doubt sessions, and discussion on previous year papers. You'll also get reading material and practice questions, which will be available on the dashboard of Olympiad Success, of which you'll get a virtual tour very shortly by Rajan sir. So students, you also get free access to Olympiad Success platform so that you can practice topic-wise mock tests for both science and reasoning. Okay, syllabus is available at this particular link, and fee you can pay by clicking on this particular link. Don't worry, all the important relevant links have been pasted in your chat box and will again be pasted. Okay, so you can avail the links from there. The fees for this particular course is 12,044 rupees, and it is going to be a 54 sessions course. So the fee includes online classes, daily reading notes and exercises, practice of previous year papers, and access to Olympiad Success platform for science and logical reasoning. All you require for these classes is a laptop or a desktop with good internet speed so that there are no hiccups, headphones for better audio clarity, and of course, as I have already told you, you need to have your camera on because we do not allow students without video in the class. So as you already have an idea that Olympiad exam is slightly tougher than your regular school curriculum. So you're required to spend at least 2 hours every day so that you can cope up with the curriculum. And of course, parental support is required to check answers and reiterate concepts, etc. So Olympiad Success has students from more than 3,800 schools across India and abroad, okay, and students from 35 plus countries. So the classes here are starting from Monday, April 10, 2023. That's all. Thank you so much. Now I would request Rajan sir to give you a virtual tour of the dashboard. All over to you.
Sure, ma'am. Let me share my screen. So I think my screen is visible to everyone. So hi students, this is the website of Olympiad Success. Okay. So I'm just showing you how you can access the content. So once you register with us for this course, we will provide you the credential. Just need to click on my account to log in. So for now, I'm going to use my credential. Okay, just wait a second. So once you register with us, we will also provide you the credential for login. Okay, you can sign in with the credential we will provide. So this is the student profile. Now all the content you will find in the live classes. When you click on live classes, you can select subject here. Okay, that is Science Olympiad. And from here, you can select the topic. So like students, for each and every topic, you will find the reading material, practice questions, and answer key here. Let me show you how it looks like. So this is the reading material for chapter acid, bases, and salt. Okay. Similarly, you will get the reading material for other topics also. Let me show you practice questions also, how it looks like. So these are the practice questions. Okay. MCQ based. And here we have answer keys. Okay. Other than that, students, we also have a schedule here. So you can check like on which session, which topic we are going to cover. Let me show you how it looks like. So this is the schedule for grade 7 science. Okay. Like in session 1, we are going to cover this topic, nutrition, plants and animal. Session 2, session 3, we are going to continue this topic. And after that in session 4, we will be having a test. So students, after each and every topic, there will be a test discussion. Okay. Now, when we complete with the test, in the end, we have the super classes. Let me show you. So these are the super classes. Okay. So like Monica ma'am mentioned, we are going to discuss previous year paper also. So in super classes, we will discuss all previous year Olympiad papers. Okay. After completing your course. Here you can check the holiday calendar, and here you will find the Zoom meeting and password for join the live classes. Other than that, like Monica ma'am mentioned, you will also get the topic wise mock test for science as well as for logical reasoning that you can access here in worksheets. You need to choose your subject. Let me choose science here. So here you can see these are the topic wise mock tests for each and every chapter. Okay. Similarly, you will get the free access for logical reasoning also. Okay. So you can also access a topic wise mock test for logical reasoning. It is very simple. You just need to click on take exam to attempt the exam. It is similar to the online exam like you have. And once you complete your mock test, whenever you want, you can check your performance here in the performance tab. When you click on performance tab, you just need to select the subject first. Okay, I think for now I don't have the access for mock test here. But once you attempt, let me attempt one mock test to show you how it looks like. Let me attempt for science. Just need to click on take exam to attempt it. Start worksheet. Choose the correct option. Okay. Then click on next for the next question. And when you complete it, just click on finish to submit. So here you get the analytics, like how many questions are there. This is the feedback form. If anyone have any feedback, you can answer. So here you will get like total questions, the time taken by you, okay, and your score. So in the performance tab, when you go, in the performance tab also, whenever you want, you can access the content. Just click on detailed result view to see your performance. This is the analytics, like how many questions you attempted, how many are correct, how many are wrong. Click on review to check. So here you can see like the correct answer, the answer you have marked, okay, and a short explanation for the correct answer, okay. So this is about the dashboard, students. If anyone have any doubt or query, you can write in the chat box. Okay, I think Mr. Vineet, I think he's a parent. Sir, you can write in the chat box if you have a doubt. We will definitely answer that.
Darshana, you can write in the chat box if you have any query. Please feel free to ask. This is the time. We'll be happy to answer.
Students, do anyone have any query or doubt?
So Dhere is asking, will all these tests be available at the start of the sessions?
Yes, once you enroll for the course, you will get the credential and you can like access all the mock test, reading material and practice questions. And that will be with you up to the like next session. Like suppose if your batch and maybe in August or July, like after that also you can access the content up to like 2024 Feb. Any other doubt, students?
So those who are raising their hand and asking to unmute, kindly type in the chat box so that we can answer your query.
Okay, let me unmute Mr. Vineet. Mr. Vineet, do you like to speak? You can unmute yourself now.
सर अभी क्या आप सुन सकते हैं मुझे?
Yes, sir.
तो मैं जानना चाहता हूँ ये जो मेरे पास मैसेज आया हुआ है ये ओलंपियाड सक्सेस, ये क्या आपका कोई नया चीज है? ये जो ओलंपियाड होते हैं ये वही है क्या?
सर
जैसे
ओलंपियाड सक्सेस सर हमारी एसोसिएशन है, ऑर्गेनाइजेशन। वी आर कंडक्टिंग क्लासेस फॉर ओलंपियाड। हम ओलंपियाड की क्लासेस कराते हैं और ये डेमो सेशन जो है वो उसी के लिए आज ग्रेड 7 साइंस।
लेकिन
आई थिंक आपने
मेरा 6 में है।
सर 6th क्लास का आई थिंक डेमो हो चुका है। आप सेम नंबर पे रिप्लाई करेंगे ना, वो आपको डेमो वीडियो शेयर कर देंगे।
कौन से नंबर पे सर?
जिस नंबर से आपको मैसेज आया है।
ये तो मेरे पास वैसे है, मैसेज आया है सर। ये तो
आपको व्हाट्सएप पे मैसेज किया होगा ना सर उन्होंने, या एसएमएस आया?
व्हाट्सएप पे नहीं आया।
व्हाट्सएप पे आया सर। मैं
नहीं,
चैट बॉक्स में नंबर शेयर कर रहा हूँ।
नॉर्मल मैसेज आया है।
सर मैं चैट बॉक्स में नंबर शेयर कर रहा हूँ, आप इस नंबर पे मैसेज कर दीजिए। वो आपको ग्रेड 6 के बारे में गाइड कर देंगे। मैंने चैट बॉक्स में शेयर किया है, आप वो नंबर नोट कर लीजिए।
एक सेकंड सर, चैट बॉक्स में एक सेकंड।
सर डू यू हैव एनी अदर डाउट?
नहीं सर, मैं ये जानना चाह रहा हूँ कि एक सेकंड।
बी मंडल, यू कैन राइट इन द चैट बॉक्स, वी विल आंसर योर क्वेरी।
नहीं, मैं तो यही कह रहा था कि ऑन से ओलंपियाड ये जस्ट ऐसे ही, चलो ठीक है, मैं समझ गया हूँ। आप सिर्फ ये टेस्ट की तैयारी कराओगे और जो आपका कुछ फीस होता है क्या आपका कुछ?
हाँ सर, आई थिंक आपने अभी ज्वाइन किया है क्या सर?
सर मैंने तो आज ही मैसेज आया ये।
नहीं, आपने स्टार्टिंग में ज्वाइन किया था ना, स्टार्टिंग से आई थिंक हमने एक प्रेजेंटेशन की थी, उसमें हमने मेंशन किया था देयर इज अ फी फॉर दिस कोर्स दैट इज अराउंड 12,044 फॉर दिस
नहीं सर,
कोर्स।
नहीं मुझे नहीं बात हो।
ठीक है सर, मैं आपको ना लिंक्स भेज देता हूँ, ये लिंक्स आप कॉपी कर लीजिए चैट बॉक्स से।
मुझे नहीं आ रहा।
और यहाँ पे आप ऑल बैच डिटेल्स में जाएंगे, वहाँ पे आपको सारी डिटेल्स मिल जाएंगी। और सर अगर आपकी कोई क्वेरी हो तो आप उस नंबर पे मैसेज कर सकते हैं या कॉल कर सकते हैं, समवन फ्रॉम आवर टीम विल गाइड
मुझे
यू।
कॉल करना है, जो कोई मेरी जो एक दो क्वेरी जो सॉल्व कर पाए तभी मैं कुछ कर पाऊँ उसके लिए।
हाँ सर, मैंने आपको नंबर शेयर किया है ना, आप उस नंबर पे कॉल करिए, दे विल। हाँ जी,
उस पर कॉल भी हो सकती है?
हाँ कॉल कर सकते हैं आप।
धन्यवाद सर, धन्यवाद
ओके
धन्यवाद।
ओके सर, थैंक यू। Okay, I think we got one more message. Can we got recording of the session? Yes, B Mandal, you will definitely get the class recordings. Okay, but like we advise students to join in the live classes, because in the live sessions you can like ask your doubts from your mentor. That is not possible in the recordings. But yeah, definitely you will get the class recordings also. Any other doubt, students?
Any other query? Sir, I don't think there is any further query.
Okay, let me ask some questions then. So students, can you tell me like what are the days we having the classes? You can write in the chat box. No, yes, not only Tuesday. We have classes 3 days. Tuesday, Saturday, I think it is not correct. Yes, Arna, it is correct. We having the classes on Monday, Wednesday, and Friday. Yes, so we having the classes on Monday, Wednesday, and Friday. Okay, my next question is what are the class timings? Class timings. 6:45, not a correct answer. 6:30 to 7:45, but it is AM or PM. You need to write the full answer. Yes, it is 6:30 to 7:45 PM. Okay, my last question. How many sessions will be there? 54. Okay, yes, correct, correct. Okay, students, so do anyone have any doubt or shall we start with the session? We can start. Okay, okay. So over to you, Aishwarya ma'am.
Thank you, sir. Okay, everyone, please switch on your videos. I think Monica ma'am has already told you guys that we don't allow students, if you don't have your videos on, please switch on your videos. I'd like to see everyone in the on screen, at least if not like face to face in reality. Yes, Rishi, Yash, Shrishti, please switch on your videos. It'll be really nice to see all of you. Okay, great. All right, so today we're going to have a demo on the chapter Light. Okay, let me just share my screen. Just give me a minute. Okay, so while I am talking about the chapter or while we're discussing any topic, what you can do if you have any doubt on any of the slides that I'm talking about, please feel free to put your doubts in the chat box. Okay, so that I also know if you understand what I'm saying or not, so you can put it in the chat box and I'll answer your queries. Is everybody, can everyone see my screen? Is it visible? Yes, no, don't know. Okay, great. All right. Okay. All right. So we're going to talk about the chapter Light. So what do you guys know about light? When I say the term light, what comes to your mind? Just 1 second. I just yes. What do you understand by the term light? It's a form of energy which enables us to see. Light is a source of energy. Light is a form of energy. It's a glowing object. Okay. All right. So anything, energy, something that glows. Okay. Yes. So it is something that glows. It is something that is, yes, it's a luminous object. Very good. So something that has some energy is light, right? And light is basically the energy that is enabling us to see any object or anything around us. Correct? Now, light can either cause reflections or it can form shadows. Correct? Depending upon what kind of light it is, what kind of object it is hitting on, or what kind of material the light is being projected on. So for example, if it's a plane mirror, the mirror that you have at homes, the ones that you see your reflection in, so what happens in that mirror? Can anyone tell me? How do you see your image? How do you see yourself? Yeah. How do you see yourself in the mirror? What happens? If you're standing in front of the mirror, what happens then? Reflection. The light reflects it. What does the light reflect? The light rays bounce back. The light reflected from the object reaches our eyes. Correct. So what is the object? What is radiating light? Your tube light. The mirror is radiating light. Sure, there is us. Okay, correct. Anna, very good. You are the object, right? You are the one which is creating, or a sort of an image is being formed of you or whatever is in front of the mirror. That will be the object that is radiating light, or the light around it is creating a radiation. or the light rays. And when that light ray hits the mirror, that light ray is reflected back. That is why if it's a dark room, you will not be able to see anything. So the mirror is not forming the light, or the mirror is not reflecting the light. Mirror will just reflect whatever is falling on it. Okay. So let's move forward. I'm unable to see your chats and the PPT at the same time, but I'll try and, okay. So what is reflection? Like we said, whenever there is a substance or whenever there's a ray of light that is striking a surface, that light, if it is completely bouncing back, we call it reflection. And the best kind of reflection can be seen in your plane mirror, which is your mirror at homes, right? So what we do is, now here when we have to understand about reflection, what we do is we take a plane mirror. Now this is kept on a flat surface. Just for your understanding, it can be in any which way. It can be kept like this also. It can be kept like this also, here also, wherever. But it is being kept like this only for your understanding. Okay. Now here we have an incident ray. Incident ray is the ray of light that is coming from the source. Source can be anything. So for example, if you are standing in front of the mirror, you are the source, right? That incident light will hit the plane mirror. And when the light is reflected back, that reflection which is being created is the reflected ray. Now, what is a normal? What is this I? What is this R? Now, what we do is, just for a better understanding, that at what angle will the reflection come out, or at what angle is the incident ray being, what is the incoming of the incident ray? For that, what we do is we create, or we make an imaginary line that is perpendicular to the mirror. So if the mirror is like this, let's say, okay, we will create an imaginary line like this, perpendicular. So normal is an imaginary perpendicular line on the plane mirror, or on the surface of the plane mirror. Okay, we represent the normal as N, capital N. Incident ray is represented as capital I, and reflected ray is represented as capital R. Okay, now the angle that is formed between the incident ray and the normal is known as angle of incidence. That means this is the angle at which the incident ray was falling on the plane mirror. Okay, and the angle that is formed by the reflected ray and the normal would be angle of reflection. Okay, any doubt till here? Anyone? Sorry, any doubt? Anyone? What? No. Okay, all right, great. So there are a few. Can I move forward? All right, let's move forward then. Okay, so mirrors. Okay, so mirror is a surface, of course, this is the definition of the mirror. The mirror is a surface usually consisting of a glass that reflects all the light that falls on it. Okay, so when we are talking about a plane mirror, we expect none of the light to get absorbed. Sometimes it happens is that we have a very distorted mirror. You must have noticed, maybe if you've gone to a circus, or you've gone to the room of illusions or something, you see yourself distorted. There are places where you go inside, there are different types of mirrors, and sometimes you see yourself very tall, very short, very fat, or something like that, correct? Okay, those mirrors have a different type of surface, because of which the image is different or it's distorted. It is purposely made like that just to cause an illusion. But a perfect mirror would be something that will take all the light and reflect everything back, absorb nothing and distort nothing. The image and the object will be exactly same. You must have noticed sometimes it happens that if you're passing by let's say a glass which is tinted or something, you might look slightly distorted, you might look fatter or thinner or shorter or taller than normally you look in your mirror. So those are all imperfect mirrors. A perfect mirror will reflect all the light that is falling on it. Okay. And whenever you see any surface that can cause any kind of reflection, or any kind of surface which is completely bouncing all the light, that is called a reflective surface. So you can see this is an example given of a lake or a water body. So if it's a still water body, a still lake, you can see your image. But if the water starts moving, then of course the image also is distorted, right? So these are the definitions of your incident ray, reflected ray, normal, angle of incidence, and angle of reflection. This I've already discussed with you. So what is this? This is the incident ray. So in this case, what have they done? They've kept the mirror like this. They've not kept the mirror flat. They've kept it like this. Now, whenever a mirror is drawn, this is just for your understanding. If the mirror is drawn like this and you make these lines means that is the polished side. Everybody's seen a mirror. What happens in a mirror? One side is a reflective side, and the other side is a polished side, right? It's polished with silver paint, correct? So when these lines, small little lines like these fringes are made, that means that's the polished side, and the opposite side would be the reflective side. Why is this important? Because if questions come, if numerical comes that the object is standing here and this is the mirror, so you have to check the reflective side. Which one can see which one? Because we can have questions like these also, that two people are standing, there are mirrors. Okay, this we'll talk about when we come to it. So this is that it is shown like this, the reflective side and the polished side. Then we have this incident ray, AO, reflected ray, BO, and the normal, NO. Okay, so incident ray, this is the ray of light that falls from the source of light on the surface. So source of light, if you are standing in front of the mirror, you are the source of light. Reflected ray, this is the ray of light which is reflected from the surface. So whatever light is bouncing back from the mirror, that is reflected ray. Normal, imaginary line perpendicular on the mirror or the reflective surface. Angle of incidence, angle found between incident ray and the normal. And angle of reflection, angle found between reflected ray and the normal. Any doubt till here? These terminologies, anyone? No. Great. Let's move forward. Okay, now there are certain laws for reflection by a plane mirror, which is very important. And these few little numericals can come for Olympiad. They can ask you according to the laws, which angle is what. First is that the incident ray with respect to the normal and the angle that is found by the incident ray with the normal will always be equal to the angle of reflection. That means I will always be equal to R. This will always be equal to this. So if this is 30 degree, this will also be 30 degree. If this is 90 degree, this will also be 90 degree. If this is 45 degree, this will also be 45. Okay. Let's say this is 27, this is also 27. Whatever may be the angle of I, that will be the angle of R, always. So questions can come on this. If 2 or 3 mirrors are placed together, incident rays coming in a certain angle, what will be the angle of R? Or you'll have to add up certain angles and find out. So it will be basic maths, but only rule you have to remember is I is equal to R. Second rule, that the incident ray, normal ray, and reflected ray will all lie on the same plane. That means it's not that the incident ray is coming here, normal you are marking like this. That perpendicular, we have to take perpendicular only, so I'll take on the other side. No. Normal will also be on the side where the incident ray is coming. And if incident ray is coming from this side, normal also has to be on this side, and reflected ray also has to be on this side. You can't have reflected ray on the other plane because it's a reflection, no? It's not passing through. So they're all in the same plane. Third rule, incident ray and and reflected ray will always be on the opposite sides of the normal. They will not be on the same side of the normal. So right now, for example, we made the incident ray here. So reflected ray is this side. Let's say I make incident ray incoming from here. Then reflected ray will go on the opposite side of the normal. Got it? Any which way you draw the ray diagram, it has to be on the opposite sides of the normal. Any doubt, anyone? No. Okay. All right, let's move forward then. If anyone has a doubt, you can raise your hand. Maybe I can unmute you because I'm unable to access the chat as of now. All right. Now, like when I said that if you go to rooms of illusion, or, there are mirrors which you feel that, maybe I'm looking fatter in this mirror, or I'm looking thinner in this mirror, or my face looks weird in this mirror, that is usually because the surface might be not so smooth. If the surface is not smooth, that means that the mirror is not completely plain, or the surface of the mirror is not nicely polished, then you can have distorted images. So before I move on to what are smooth surfaces and what are rough surfaces, first of all, you have to understand is, now when I'm talking about an object, if I am standing in front of the mirror, obviously it's not possible that only one ray of light will come from me. So let's say this is the mirror, this is the polished side. Okay, this is the reflective side. I'm standing in front of the mirror, though I don't look like this, but just for your understanding, okay, it's not necessary that only one ray of light will come like this, no? Okay, it will not just come from my face. My entire body, I am the entire object. Everything will be reflecting light. Okay, so many incident rays will be coming in. Just for our understanding, we were drawing one reflective ray and one incident ray, but multiple rays are coming in. So what you have to understand is that all the incident rays that are coming in from a object, they will all be parallel to each other. See, they are all parallel to each other. They will not come like this haphazard manner. No, they will all be parallel to each other. If it's a smooth surface, if it's a good mirror, then all the reflected ray will also be parallel. Okay, that is when it will give you a good image. So reflection of light from a smooth surface is called a regular reflection. In a regular reflection, there will be parallel beams of incident ray, and they will all be reflected back in the same direction in the parallel form. So plain mirror has to be highly polished. Any kind of good metal object can also act as a plain mirror if it's a good polished metal, like a nicely clean spoon or something like that. But spoons are curved, but if it's a flat surface, they can also act as mirrors. And images formed by all these are regular images. Now let's say if the surface is slightly rough, then what will happen? Then you will get distorted images. So if there is, the surface is rough. So if you see here, if you go back, this was a smooth surface. If I go here, this is a rough surface. So whenever there's a rough surface, incident ray will still be parallel because the object is the same. From the object, the incident ray is projecting out. So incident ray will all be parallel only. Incoming will be parallel. Only thing is, once they hit the surface and the reflection is reflected back, all the reflected ray can go in all different directions. And that is when you get imperfect reflections or distorted images. Okay? Any doubt? No. Great. So this is how it looks like. This is a regular reflection of a smooth surface. Incoming is parallel. That means all incident rays are parallel and all reflected rays are parallel as well. Whereas in a rough surface, you have incident ray parallel, but reflected ray are going in all different directions. Okay. Okay, now coming to different types of images being formed. So whenever we are standing in front of a mirror or I'm looking at an object, the image that is being formed of the object might appear different to me. Sometimes it may appear smaller, sometimes it may appear bigger, depending upon what kind of a mirror we are talking about. Now, when I say a plain mirror, plain mirrors are the mirrors that we are using at homes. Okay, But you must have seen there are different types of mirrors also being used. For example, the mirrors that are used in your cars. Have you seen the rear view mirrors, the ones on the side of the doors? It is written, if you've not seen, next time you can see. It's written there that the objects that appear in the mirror may be closer than it seems. That means in the mirror, the object is looking much smaller and it feels that it is very far away, but it might be closer in reality. That is because those are different kind of mirrors. We are using either convex mirrors or concave mirrors. Okay. Now, what is a convex mirror, concave mirror? Can someone tell me? You can raise your hand. I'll unmute you. What is a convex mirror? Does anyone know? Mirror I'm talking about, not lenses. Mirrors. Does anyone know? You can give it a try. Maximum, you'll be wrong. That's fine. We're all here to learn. Yes, Arna, can you tell me what is a convex mirror? You can unmute yourself.
Yes, ma'am. Ma'am, it is a type of mirror. It is a spherical mirror, which is a part of sphere.
Correct. It is a part of sphere. So a convex mirror usually, so it's a part of a sphere. So mostly what happens, this is the reflective surface like this. This is the polished side and this is the reflective surface. So since it's a curved surface, what will happen whenever the light is falling on it, the light can either converge or diverge because it's not a smooth plane surface. No, we already saw that if it's a smooth surface, all the reflective ray will go back parallel. So they'll never meet each other. Okay. But if it's a curved surface, then of course the reflective ray can divert from their parallel path. What is a concave mirror? Concave mirror will be opposite. That means that is also a part of sphere only. So this is convex. Concave mirrors would be opposite. That means this would be the reflective side and this would be the polished. So is inwardly curved. So here the light will fall. This is a concave mirror. Okay. Now, depending upon whether the reflective ray or the rays of light are converging or diverging, we have two types of images. Any doubt till here? Convex mirror, concave mirrors? Doubt? Any doubt? No? Yes? Okay. So now what happens is, if we have in a similar situation, let's take lenses. Okay, like our eyes have a lens, right? So that is how we can see objects, correct? People who wear specs, they are also wearing an additional lens because maybe their eyesight or their lens is not working properly. So now if you're talking about a convex lens will be like this. Okay, that means this part can reflect the light, and concave would be like this. These parts can reflect the light. About lenses have both the sides. We will talk about lenses also in detail. So here both the sides can be used for forming the image. Now, whenever, just listen to me very carefully what I'm saying. Whenever the rays of light, they get reflected and they meet in reality. That means if these are the incident light and this is striking on a surface and they actually meet in reality somewhere, or let's say we talk about reflection. So when the reflection is happening, they are meeting at a certain point. When they're actually meeting in reality, we call it a real image. Okay. In case of a plane mirror is smooth. So what happens in a plane mirror? Plane mirror, all the incident ray comes like this, or I'll draw it like this for better understanding. Incident ray is falling parallel and reflected rays going back parallel. So these are reflected ray, these are incident ray. These are incident ray, reflected ray. Do you think in a plane mirror, the reflected ray will ever meet? If it's a smooth plane surface, do you think the reflected rays reflecting from a smooth plane mirror will meet? Yes or no? Very simple answer. Either it could be yes or it could be no. How many of you think that these reflected ray can meet later somewhere? Do they meet? Anywhere? Nobody thinks they meet? Yeah. Yes, no, don't know. Yes, Arna? What do you think? Will they meet? Will they not meet? Anna, you can unmute yourself. I think.
Yes, ma'am. Ma'am, actually, it does not like we cannot see the rays meeting, but it actually meets behind the mirror virtually.
Correct. So, like I said, that these incident ray, if they are falling parallel on a smooth surface, when they get reflected back, reflected ray are also parallel. That is what we've understood. If it's a smooth surface, reflected ray are also parallel. If two lines are parallel, they'll never meet in reality. Yes, any two parallel lines, if they are going parallel lines, the main definition is that only that they are running parallel to each other and they will never intersect. So if they are never intersecting, they will never form a real image. So what we do is they meet imaginary, or they make a virtual image behind the mirror. So we imagine it like this, that behind the mirror, they are meeting somewhere here. And that is how we see the object. The image, that means if an object is standing here, the image is seen behind the mirror. Yes or not? You see it inside the mirror, no? Your reflection is seen inside the mirror, not outside the mirror. Though the reflective ray is coming out, but we are seeing the object inside. If this kind of a situation happens where in reality the reflected ray are never meeting, but they meet virtually, then we call it a virtual image. Virtual images are always erect. That means they are always upright. Whatever is the object, they will look exactly like the object upright. That means if I'm standing straight, my image will also be straight only. It's not that my head will be on the ground. It will be erect. Real images are always upside down. So they are always inverted. So this is how we identify a real image and a virtual image. So whenever a real image is formed, usually real images are formed in case of lenses. Mirrors, plain mirror will always form a virtual image. It'll be very weird if you're standing in front of the mirror and your image comes upside down. Very scary, very weird also. Defeats the purpose of having a mirror altogether. Okay, but some of the lenses at different positions that we'll study when we talk about lenses, that at what positions can the lens make virtual images, and at what places the lens can make a real image. So in a real image, everything will be inverted. Okay, that means it will be upside down, right? So you just have to remember that if the reflected rays are converging or they are actually meeting in reality, then it gives a real image. Real images are always inverted. And in reality, if they are not meeting, then imaginary lines are meeting somewhere. So they are forming a virtual image, and the virtual image will always be erect. Okay. So images formed are of two types: real image, formed by actual convergence or meeting of the light rays, and real images always form on a particular screen. The screen can be anything that we'll study later when I talk about screens. And a virtual image is the apparent convergence of the diverging ray light. That means actually they'll never meet, but we'll make them meet somewhere virtually. And virtual images cannot be obtained on a screen. By this definition, can you tell me, do you think everybody's gone to a movie hall to watch a movie, right? Sometime or the other, maybe before COVID, maybe after COVID. Sometime or the other, you must have seen a movie in the hall. What happens in the cinema hall? There's a projector, correct? Projector is projecting the images or the movie on the screen. Yes? Now, of course, we have digital projectors, but still, that is how basically it works. So do you think the images that are being projected by the projector, is it real or is it virtual? Going by the definition that real images always form on a screen. Virtual images cannot be obtained on a screen. That means if you're seeing your reflection in the mirror, that reflection cannot be obtained on a blank screen. If I put a white screen or a black screen, you'll not be able to see that reflection. It gets blocked out. But if it's a real image, you can get the projection on the screen. That is how your cameras work. That is how your film rolls used to work. And that is exactly how your movie projections work. So a projector or an image that is being projected from the projector is a real image. That is why you can see it on screen. Then how is it not upside down? Imagine you went to see a movie and the actor and the actresses are running upside down. Why is it not upside down then? Why is it erect? Yes, Neha.
Ma'am, it is not upside down because it is upside down within the projector.
Correct. Very good. So initially only they put it upside down. The film roll or the inside the projector only it's inverted. So when it is getting projected on your screen, it is accordingly, in reality, it is upside down, but it is being projected as straight to you. Got it? So if you see the film rolls, it's upside down. And then when it comes on screen, it becomes straight. Got it? Any doubt, anyone? Okay. All right. So this is an example of a real image and a virtual image. So this is how, when a person is standing in front of the mirror, the reflective rays cannot meet. So virtual image is being formed. Okay, there will be no convergence. So first of all, the image which cannot be obtained on a screen is a virtual image, and the image formed of our face, of our body, anything on the mirror is always a virtual image. And the image which you can actually have an intersection of when the convergence happens, that is a real image. And I already told you there are 3 types of mirrors. We have a plane mirror, convex mirror, and a concave mirror. So every different type of mirror can give you a virtual or a real image. This is important. This we will talk about in detail when we come to live classes, in terms of when I start actually taking the class. Then we'll talk in detail about the different scenarios in which a convex and a concave mirror work. Plane mirrors will always give you virtual image. There is no exception at all. Okay. Only thing about a plane mirror before I move on to virtual images. There are a few things that you need to know about a plane mirror. Just going back to the plane mirror. First, the image and the object will always be of the same size. That means if the object is 5 feet tall, image is also 5 feet tall. If the object is 5 meter wide, image is also 5 meter wide. Object and image size is same. Second, distance of the object from the mirror is equal to the distance of the object of the image from the mirror. That means if you're standing 2 meters away from the mirror, your reflection will be 2 meters away from the mirror. Okay. Third, it is always a virtual image. You can write these things down. Third is, plane mirrors always form a virtual image. Okay. And fourth is, there will always be lateral inversion in the reflection of the object. That means when you raise your right hand in the mirror, what can you see? It becomes left. Correct? And left becomes right. So it is just lateral inversion, side by side inversion, nothing else. Yes, Neha? I can't hear you.
Ma'am, I don't have it.
No, okay. All right. So I'll just quickly write down the points. First, size of object always equal to size of image. Okay, sizes are equal. Second, distance of object from the mirror equal to distance of image from mirror. Third, it's a virtual image. Always a virtual image. And fourth, there is always lateral inversion. That is why, since it is a lateral inversion, you must have seen in front of the ambulance, it is written in the reverse form, so that when you see it in the rear view mirror, somebody who's driving in front of the ambulance can see it in the rear view mirror. Rear view mirrors are plane mirrors only, and they can see that a ambulance is coming behind them. They can read properly. Okay, any doubt? So simple questions can come. For example, let's say this year, not this year, previous year, there was a question that, let's say, this is an image that is, this is a word that is written. This is the mirror. What is the reflection of the word seen in the mirror? And different options were given. Okay. So simply what you can do is one by one, you can take the starting from the nearest one, we'll start. So B will be like this. L will be this. U remains U only. U, I, H, O, these are letters that remain the same only. They don't usually get inverted. And last B, B will also be like this. Correct? So you have to select the correct answer. Different options would be given to you. Right? Similarly, distance questions can also come. So I'll give you a question. You can solve that. Any doubt in this so far, anyone? Yes, no, couldn't understand anything. Is there someone who's not able to understand what I'm saying or what I'm writing? Or is there anyone who can't understand my handwriting? Is it okay? Okay, great. All right, so I'm giving you a question. Everyone needs to solve this, and you can raise your hand if once you've got the correct answer. Or you can put it in the chat box. I'll close this for a while. Okay, question is that, just 1 second. Okay, question is, just listen to the question. There is a mirror kept here. This is the reflective surface of the mirror. Okay. An object is kept, oh wait, I'll just draw the mirror here somewhere. This is the mirror. This is a pencil, or let's say there is a candle kept here. Okay. This candle is about 3 meters from the mirror. Okay. There is a person standing here. This person is 2 meters away from the candle. Right? At what distance will be the image of the candle from the observer? At what distance will be the image from the observer? You can put it in the chat box, your answer. Please send me a direct message. Don't send it to everyone. Yes, Atharva, you have the answer? Or you have a doubt in the question? You have the answer. Okay, can you put it in the chat box so that everybody can also answer? Everyone put it in the chat box, but send me a direct message, please. Put it in the chat box, everyone, quickly. Nobody's giving me the correct answer. I am asking, what is the distance of the image from the observer? Anna is correct. Only one correct answer I've got. Anna. Very good, Anna. Think about it. No. First, find out what is the distance of the, where will the image be formed? Still wrong. Only one. Yes, Shreya. Very good. Correct answer. Yes, Atharva, correct answer. Shreya has already given it to everyone. So now everybody knows the answer. The correct answer is 8 meters. How is it 8 meters? Because where will the object or where will the image be formed? I said the distance of the image will always be equal to the distance of the object from the mirror, correct? So distant object is what? The candle. Image will be found where? Here. Sorry. Image will be found here. So image will be found at a distance of 3 meters only. And what did I say? So let's say this is the image. And I asked you, what is the distance of the image from the observer? So 3 plus 3 plus 2, 8 meters. Got it? Any doubt, anyone? How did we get 8? Right? So this is a simple question that can come. More difficult can also come. Of course, when we proceed in the chapter, we will increase the level of difficulty as well. This is just the first few classes. Any doubt, anyone? All right, great. Let's move forward then. Okay, so this is about plane mirrors. Now, this we've already done. Okay. Now, these are a few pictures, or these are a few, let's say, few of the characteristics that are that we are talking about a plane mirror again. So the plane mirror and the image formed by it. So virtual image is always formed. Formation of a virtual image by a plane mirror. So this is the incident ray. This is the reflection. This is what you can see in the reflection, but actual conversion is not happening because these reflected rays will go back parallelly only. It's not shown parallelly. In reality, it will go parallel. This diagram is slightly wrong. Both incoming will also be parallel, outgoing will also be parallel. And here it will meet virtually. And that is why we can see the image right where the object is. Okay. So this is what I was telling you about characteristics of the image formed by a plane mirror. First, the image is always erect because it's a virtual image. Image is the same size as the object. Image is laterally inverted. Distance of object from mirror is equal to the distance of the image from the mirror, and the image formed is always virtual. Okay, and this is how we represent a ray diagram. So this is the incoming, this is the incoming, and these are the outgoing, and here somewhere virtually we are trying to meet them. So the image will be found behind the mirror. Okay. Now, of course, it is laterally inverted. So this is showing lateral inversion. If it's written mirror like this, it will be the opposite side. Your right will be left, left will be right. Height is same. H1 is equal to H2. Size is same. Everything is same, and distance is same. A is equal to B. Okay, I'm skimming through this because we've already discussed this in detail. Okay. So this is again the same repetition. Like I said, ambulance is usually labeled upside down. Sorry, not upside down. It's in the reverse form, so that somebody, if they are driving in front of the ambulance, they can see it clearly, right? Okay, let's look at the uses of the plane mirror. First of all, plane mirrors widely used at our homes so that we can look at ourselves, look at the objects clearly. Second thing is that these are fixed on the walls to provide false dimension in showrooms. Basically, the showrooms or even in your houses, if you have mirrors, it gives an illusion of a bigger room because everything in the room will be reflected back. So it gives the size as a bigger size. That's it. And even when you go to showrooms and all, or you go to trial rooms and all, the placement of the mirror is such that if you're standing at one point, you can see all sides of yourself, at the back, at the side, like how does the garment look on you from all sides. So that also can be used. And they are also used in kaleidoscopes, periscopes, and solar cooker, just so that all the light can be converged together and a sort of an illusion can be created. So these are the different uses. Okay, now coming to this. Now let's say if there is a mirror and another mirror is placed along with one mirror. So let's say you go to a trial room. I'm sure everybody's been to a trial room sometime or the other, seen a trial room at least. So you see multiple mirrors there, at least minimum of 2 mirrors are there. Obviously, either they're usually perpendicular to each other, correct? Or there can be 3 mirrors. The moment you enter the door, there'll be 3 mirrors. So like I said, when you enter the trial room and you try on a garment, what you can see is that you see yourself from the back, from the side, from the front. It is basically giving you the view of the entire garment and how it looks on you. So how will you know how many kind of images are formed by these mirrors? Because they'll keep on reflecting, no? One image will form a reflection. That reflection can act as the object for the second mirror. Then they'll keep reflecting back. That means you can see yourself in the mirror. The image can form another image inside the mirror. So how many images will be formed? Will it be infinity? Image inside image, inside image, inside image. How will you find out? This is a formula to find out. Okay. So how will you find out? First of all, you'll find out what is the angle between the two mirrors. So most of the times for class 7, grade 7, Olympiad, we have only uses of two mirrors. That means questions on only two mirrors will come, not more than two mirrors. If there is a question more than two mirrors, one of the mirror will usually be placed parallel to the first mirror or the second mirror. So you will have to see the question carefully. But for now, we are only talking about two plane mirrors. So first you will find out the angle between the two plane mirrors. So let's say this is one plane mirror and this is another plane mirror. Okay. This is the angle between the two mirrors. This angle is represented as theta. So this in the formula, the theta is the angle between the two mirrors. So this is mirror 1, this is mirror 2. What first you'll do is, you will calculate what is 360 by theta. First, you will find out what is 360 by theta. Okay, so let's say these two mirrors, I'll draw, let's say, a parallel, perpendicular mirror so that it's easier to calculate. So theta is 90 degree here. So 360 by 90 degree. What is the answer? 360 by 90, quickly calculate. Easy maths. Four. 9 fours are. What is the answer? Anyone? 360 by 90 degree, quickly can calculate. I can't see any. You can put it in the chat box, everyone, whoever's calculating the answers. Yes, Anna?
Ma'am, 3 images will be formed.
No, but tell me what is 360 by 90 first. What is 360 divided by 90? Yes, Atharva.
Ma'am, 40.
40 or 4?
Ma'am, if we cut the zeros, it will be 4. The otherwise, it's 40.
No, in any case, it will be 4 only, no?
Yes, ma'am.
In any case, it will be 4. Okay. So here, they had already told me it's 4 by telling me it's 4 like this. Okay. So this comes out to be 4. Now, listen to me carefully. If 360 by theta comes out to be an even number, okay? If 360 by theta comes out to be an even number, we will subtract 1. If 360 by theta is an even integer, this is the formula that you use. That means you'll simply subtract 1. So the number of images formed here will be 3. And this is what Anna was saying. That number of images formed at a 90 degree angle will be 3. Okay? Any doubt here? If 360 by theta is an even number, we subtract 1. Okay? Number of images? 3. If 360 by theta is an odd number, so in any which way, most of the times it will be an even number only. But let's say theta comes out to be an odd in any scenario. I'm not going into detail. We're not doing many calculations right now. So if 360 by theta comes out to be an odd number, so let's say it has come out to be, let's say 5. This calculation has come out to be 5. We'll not do anything. We'll keep it as 5 only. No subtraction, no addition. If 360 by theta is odd, that is your answer. That is the number of images that are formed. Till here, any doubt, anyone? If it's even, you subtract 1. If it's odd, you let it be like that only. You don't do anything with it. Yes, Neha? You can mute yourself on your own. No? Okay.
Ma'am, so the number of images formed is always odd.
Mostly. I'm coming to that next. Any doubt till here, anyone? Odd even? No. Okay, next. Now, sometimes it may so happen that 360 by theta is not completely divisible. Right? It's not necessary that it comes out to be a complete even integer or an odd integer. So let's say it comes out in points. So let's say it comes out, let's say this you divide anything, any number is being divided. Just 1 second. Any number has been divided and this comes out to be 2.3. Your fraction comes out to be 2.3. Then what will you do? Can there be a 0.3 image? If you are a whole person, you can't see yourself 0.3 in a mirror, no? If you're standing in front of the mirror. So then what we'll do? We'll take the whole integer only. So the number of images formed here is only 2. Got it? Even if the integer has come out to be 2.9, then also we'll take it as 2. The whole integer will be taken, fraction will be ignored. So Neha, this answers your question. In these cases, it will be an even number. Got it? Any doubt, anyone? Yes, no? Okay. All right. That's it. So this is how you will calculate. Now, sometimes placement of mirrors can be given very easily, that this is the mirror, this is the angle, calculate the number of images formed. Or in some cases, there can be multiple mirrors. You have to find out which 2 mirrors are making an angle and calculate between them and then calculate the total number of images. So for example, if I say that there are 4 mirrors kept like this, so you will not bothered about what is form, will this image form an, will this reflection form an image here or not? Forget about that. You just have to calculate the number of images formed between these 2 mirrors, the number of images formed between these 2 mirrors, and give the answer as to whatever is asked. Because in your syllabus, there are only 2 mirrors as of now. Got it? Shall we move forward? We'll do numericals on this when we come to the regular classes, of course. Don't worry about that. So this is a normal mirror that is being placed, 2 mirrors that have been placed. This is the object, right? And there are certain, we will, when we practice the questions, there are certain questions that also take into consideration whether the object is placed symmetrically or not. That also makes a difference. So for example, what do you mean by symmetrically or not? Let's say these are the 2 mirrors. Okay, they're at 90-degree angle. And if the object is placed right here, then it's symmetrical. Why? Symmetrical means it's placed at a symmetry. No, it's right in the middle of this mirror, right in the middle of this mirror. So it creates a sort of a symmetry. Then the number of images is certain that this will be the number of images. This we'll talk when we come to regular classes as to how do you calculate. Now let's say if the same placement of mirror is there, but the object is placed somewhere here. This is not symmetrical, no? It has a lot of distance from this mirror. So it might affect the reflection. And this is closer to this mirror, but this is placed at the edge of the mirror. So then the number of images might vary. What is that variation? That I will speak to you when we come to regular classes. Got it? As of now, you can just remember the 3 things that I told you about: odd, even, and a fraction. If this scenario comes, these are very unlikely questions, but yes, they've come in the past. Mostly you will get symmetrical objects only, so you will just simply put those formulas and do the questions. If not, then we'll talk about it. Okay, so I'm going to stop here today. Of course, there's a lot to do in light, and light is one of the initial chapters in the session. So hopefully I'm going to see you whenever we start with our regular classes. I'll see all of you in the regular classes, right? And we'll talk about it. Now, I just want one thing from you guys, slightly. See, in these classes, you're all on mute, but in the normal classes, in the regular classes, you will all be allowed to unmute yourselves. So I need you to ask questions, not sit here quietly for 1 hour, 15 minutes, because it gets boring for you also. It'll get boring for me only, if I only keep on talking, right? So I want you guys also to talk, and we will have a simple, very interactive session. Okay. And you can, even if you feel shy, it's fine. Over the entire few months that we'll be together, you'll obviously get to know each other, get to know me also. So I want you guys to talk in class as much as possible. Right? So be slightly more interactive, be attentive in class, of course, and please switch on your cameras. Otherwise, I'll not be able to allow you in class. People who've switched on their cameras, sometimes I know it can be an issue that you don't have internet or something like that. But most of the times I want to see you. That is how I'll know you. So for example, I know like for now that how does Neha look, how does Arna look, how does Atharv look. So when you come to my regular class, I know this is who, right? I'll be able to recognize you. But students without the camera, how will I recognize you? How will I know who's who? You know me, I don't know you, right? So that's it. I hope you guys enjoyed. And I'll see you in the regular classes. Okay? Have a great day, everyone. Thank you for joining. Bye-bye. Have a great day.